Welcome to week 13 for Algebra 2. It does say Algebra 2 Honors here, but it is also for my regular Algebra 2 class. So when you see this, make sure you please know that this does not just include honors, that it is also for just my regular Algebra 2 class. In this week's lesson, we're going to learn how to rationalize the denominator. Please make sure to complete your warm-up, fill in your table of contents. Remember, the warm-up will look different for each class, more than likely. Since this is SAT questions, I may keep some of these SAT questions because everyone will be taking the same SAT. You will need a piece of paper for this lesson, as this is not a student journal page. And dividing radicals is also known as rationalizing the denominator. You'll need a piece of paper. To divide radicals, you have to first realize that to be in simplest form, the denominator should not be irrational. To be irrational means that you have a radical in the denominator. To fix this problem, it's called rationalizing the denominator. There's an example pictured here. You've got 1 divided by the square root of 2. I need to simplify that. How do I simplify? Well, if you notice, look at this right here. What have they done to simplify? They've multiplied by 1. The square root of 2 divided by the square root of 2 is 1. So they really haven't changed the value of 1 divided by the square root of 2. They've changed the appearance. Now I want you to look. 1 times the square root of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So we're going to rationalize the denominator on each of these. Looking at number 1. I want to get rid of the square root of 3 out of the denominator. How do I do that? I multiply by the square root of 3. 5 times the square root of 3 is 5 square root of 3. Square root of 3 times the square root of 3 is the square root of 9. I can simplify that square root of 9 into 3. So my answer is 5 times the square root of 3 divided by 3. For question 2, that looks weird. It doesn't look like the initial example and the example that you see for number 1. Let me mention something really quickly. You do not have to write this down. I do recommend that you write this down and write this down. Back to number 2. The square root of 2 sevenths can also be rewritten as the square root of 2 over the square root of 7. Now to rationalize, I multiply the numerator and the denominator by the square root of 7. Since 2 and 7 are both under a radical, I can multiply them. 2 times 7 is 14. The square root of 7 times the square root of 7 is the square root of 49. And I have the square root of 14 over 7. That's my answer for number 3. Excuse me, number 2. For number 3, I see that I can actually simplify that radical. There's a perfect square in that radical. 4 times 2 is 8. The square root of 4 is a perfect square. So before I can do anything, I've got to get that perfect square out of there. So the square root of 4 is 2, and then just bring down your square root of 2. Now I can rationalize. I'm going to multiply the numerator and the denominator just by the square root of 2. 5 times the square root of 2 is 5 square roots of 2. Bring down that 2 that's on the outside, this one right here. And then square root of 2 times square root of 2 is the square root of 4. 5 times the square root of 2 over 2 times 2, because the square root of 4 is 2, And final step, and I know it took me a lot of steps to get there. 5 times the square root of 2 over 4. That's the answer to number 3. Number 4 is the same as number 2, so I'm just going to write same as number 1. And you can do the same thing. Put number 4 and put same as number 1. I would change it, but that'll save time if I just do that. Okay, so for number 5, I'm going to go straight to rationalizing because I can't simplify that square root of 2. I have 40 times the square root of 2 over the square root of 4. The square root of 4 is 2. And then 40 and 2 can reduce. 40 divided by 2 is 20 times the square root of 2. That's the answer to number 5. Okay, let's go on to the next. Sometimes the denominator is a binomial with a radical in it. You still have to rationalize the denominator. You have to multiply by the conjugate to simplify. This simply means to change the sign of the binomial. If it has a plus sign, make it a minus sign, and vice versa. So we're going to find the conjugate. The conjugate of 3 plus the square root of 5 is 3 minus the square root of 5. The conjugate of 7 minus 2 times the square root of 3 is 7 plus 2 times the square root of 3. The conjugate of the square root of 3 plus the square root of 2 is the square root of 3 minus the square root of 2. We're going to use that skill to do the next examples. And the conjugate, remember the conjugate, I'm going to write this at the bottom. The conjugate is only used when you have a binomial. And that is when you have addition or subtraction signs in the denominator. Oops. See, I can't talk and write at the same time. Binomial. Addition or subtraction signs in the denominator. If you just have a monomial, which does not have an addition or subtraction sign, then you would just multiply by the conjugate. Now, when I look at number 9 is complicated. I see I have some perfect squares, 48. And if you don't have a lot of experience with this, let's talk about perfect squares. I want to take 48 and think about all the factors of 48, things that will multiply to give me 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Do you see a perfect square in that list? I do. 16. So when I come down here, before I can even rationalize, think about getting rid of that square root in the denominator, I need to get that perfect square out from underneath that radical. Let's do the same thing for 75. Factors of 75. 1 and 75. 2 does not go into 75. 3 and 25. 4 does not go into 75. 5 goes in 15 times. I think that's it. And I do see a perfect square. Here's a perfect square. So I'm going to use the square root of 25 times the square root of 3. I don't have any perfect squares in the denominator. Next, I'm still working in my numerator because I need to take the square root of 16 and the square root of 25. The square root of 16 is 4. The square root of 25 is 5. I'm going to multiply that 5 and that 4. And now I'm going to rationalize. Oh, actually, hold on. Those are like terms. 20 square root of 3 plus 5 square root of 3 is 25 square root of 3. I'm not going to have to rationalize on this one. And I have 5 square root of 3 on the bottom. This is all multiplication, so I can cancel out the square roots of 3. Square root of 3 divided by square root of 3 is 1. 25 divided by 5 is just 5. I did not even have to rationalize number 9. Number 10, I am going to have to rationalize. I need to multiply the numerator and the denominator by the conjugate. 2 plus the square root of 2. To multiply, I have to distribute. I'm going to write that down here. I'm going to write that out. 4 plus the square root of 2 times 2 plus the square root of 2. Divided by 2 minus the square root of 2 times 2 plus the square root of 2. I have to distribute. 4 times 2, 4 times square root of 2. Square root of 2 times 2, and square root of 2 times the square root of 2. And same thing on the bottom. I have to distribute. And let's see what we get. 4 times 2 is 8. 4 times square root of 2 is 4 square roots of 2. Square root of 2 times 2 is 2 square roots of 2. Square root of 2 times the square root of 2 is the square root of 4. 2 times 2 is 4 on the bottom. 2 times the square root of 2 is positive 2 square root of 2. Negative square root of 2 times 2 is negative 2 square root of 2. Negative square root of 2 times positive square root of 2 is negative square root of 4. Let's simplify in the numerator. I have 8 plus 6 square roots of 2 plus 2. In my denominator, I have 4, 2 square root of 2 and negative 2 square root of 2 cancel out, minus 2. And then to finish, in the numerator, 8 and 2 still can combine. And then 4 minus 2 is 2. And I thought I was finished, but unfortunately I'm not. I need to simplify. This is a fraction I need to reduce. I need to check these 3 numbers that I'm highlighting. Do those 3 numbers have a common factor? And yes, they do. They have a common factor of 2. So I'm going to divide them each by 2. Just those numbers, never anything that's under the radical. 10 divided by 2 is 5. 6 divided by 2 is 3. Keep your square root of 2. 2 divided by 2 is 1, but I don't need that 1, so I'm going to erase it. And so my answer is 5 plus 3 square root of 2. Okay, I'm going to rewrite number 11 at the top because I don't have space there beside of it. I don't have any radicals that can be simplified, so I'm going to multiply by the conjugate. Somehow, all my audio for this particular page was deleted. So you can see all the writing that I have done. Each of these I have rationalized the denominator. If you need me to do a video to explain each of these, just let me know. I apologize for the audio to be deleted. I do not know what happened. So if you need help with any of this, I believe you can see all of my work and that you'll be okay there. But just let me know and I'd be happy to do a video where you can actually hear me doing these examples. This is your assignment for the week, your practice. 1 through 24, you do not have any book work this week. For my regular Algebra II classes, if you need help with any of these, let me know. I'd be happy to do videos to help you. I believe I will go ahead and tell you, you do not have to do number 10. I believe that's the only one. The rest of them I think you'd be okay doing. I'd say my regular Algebra 2, you do not have to do number 6 or number 4. But we can talk about that later. My regular Algebra 2 classes, you will have an assessment here to complete. For my remote learners, my honors classes, you will receive your assessment either in class or just the same way we've been doing assessments the entire semester. Hope you have a wonderful day. Reach out if you need help.